In this example, I'm going to work through a redox reaction. In this redox reaction, magnesium metal dissolves in copper 2 sulfate solution. The result is a copper precipitate and aqueous magnesium sulfate. This is quite similar to the reaction that you performed in the lab. To write the reaction, we'll start with the magnesium metal. The magnesium metal reacts with the copper 2 sulfate, which is aqueous, and the result is some magnesium sulfate, which is aqueous, and solid copper. We know that magnesium, because it's a group 2 metal, forms a 2+ ion. Copper 2 is a 2+ because it's copper 2. Sulfate is a 2-. So the 2+ of the magnesium and the 2- of the sulfate are balanced out, and we get copper, solid copper, as our other product. So this is a 1-to-1 to 1-to-1 reaction, which makes it quite easy for us to write this balanced reaction. The next step is to write our oxidation and reduction half reaction. When we write our oxidation and reduction half reaction, we first want to start with anything that changes. So in the case of magnesium, solid magnesium has no charge. Now, in the product, magnesium is an ion and it's associated with the sulfate. Because magnesium is a metal, it makes a cation. So the solid magnesium is transforming into magnesium ions. And those are 2+ ions, and they're aqueous. This is the first part of our half reaction. We have one magnesium atom becoming one magnesium ion. The other part of balancing this half reaction is that we need to balance the charge. On the reactant side, magnesium metal has no charge. On the product side, magnesium ion has a 2+ charge. The only way that we can balance charge is by adding electrons. Electrons have a charge of -1. Since the reactants have no charge and the products have a 2+ charge, we need to add 2 electrons to balance the charge. The fact that electrons are a product means that magnesium, when it becomes magnesium ions, is losing 2 electrons. Electrons are a product, electrons are lost, so this is our oxidation half reaction. The other species that changes is our copper 2. We start as copper 2+ ions because they're associated with these sulfate ions. They are aqueous, and they transform to become solid copper when the reaction takes place. We have our mass balance because we have one copper ion becoming a copper atom, or metallic copper. In order to balance the charge, we need both sides of the reaction, the reactants and the products, to have equal charge. At the beginning right now, the reactants have 2+ charge. The products have no charge. In order to balance out 2+, we need to have 2-, and the way that we balance charge is by adding electrons. So we're going to add 2 electrons to the reactants. So copper 2+ gains 2 electrons to become metallic copper. Because copper 2+ is gaining electrons, electrons are in the reactants, therefore that is the reduction half reaction. And now you've written a balanced redox reaction, you've written an oxidation half reaction, and the reduction half reaction.